Equations of a line can be written in several different forms, each offering a unique and different perspective. Today we're going to be breaking down three major forms. We're going to be looking at the point slope, the slope-intercept, and the standard or general form. They all describe the same line, just from a different angle. And knowing when and why to use each of them can help you significantly in algebra. So let's go ahead and first start with the point slope form. The point slope form has a general formula of y minus y1 is equal to m times x minus x1. So we use this form when we have the slope and any point on the line. Normally we won't use this if we have the y-intercept. We'll save that for the slope-intercept form instead. This form is very fast, very flexible, and local, and it's perfect for calculating other points on the line quickly. It's not the easiest for graphing, again that goes to the slope-intercept form, but it's really useful when you just need to find another point on the line. So let's go ahead and look at an example of this. Let's move this actually just slightly. So let's go ahead and first start with defining our known slope, which here is going to be 3, and a point on the line, which we're just going to pick 2, 5. So we plug in these two values, y minus y1. Let's go ahead and label y1 and x1. So y minus 5 is equal to 3 times x minus 2. Now, we can pick whichever y or x we want and find the corresponding x and y for that value. So for example, if we want to know what is the y value when x is equal to 4, then we plug this into the equation and solve for y. So y minus 5 is equal to 3 times 4 minus 2. This becomes 2, and then 3 times 2 is 6. So we get y minus 5 is equal to 6, or y is equal to 11. So what we just did here was we found a point on the line, which is 4, 11. And that's really what this form is used for, being able to quickly find another point on this line. And also, don't get confused here with the minus signs. I know it can look a little confusing, but if we have minus 5, then y1 is 5. If we had y plus 5, then y1 would be negative 5. Okay, let's go ahead and move on to the slope-intercept form. The slope-intercept form is extremely useful in graphing. And if you want to see how you can use it to graph, make sure you check out this video right here. So again, let's go ahead and look at the general formula for this line equation, which is just going to be y is equal to mx plus b. This is probably the one that you're most familiar with. You've seen it dozens of times throughout algebra, pre-algebra, and the reason why is because it's perfect for graphing. We're not going to use it for graphing right now. We're instead going to use it to find another point on the line, like we did previously with the point slope form. So let's go ahead and set up an equation. Let's do y is equal to 3x minus 1. So here, our slope is 3, and our intercept is negative 1. Now we can plug in whatever value for x we want and find the corresponding y value. So for example, let's go ahead and find the y value when x is equal to 5. So we go ahead and plug 5 in for x, and then we just solve. So here we see that y is equal to 14, or we know the ordered pair 5, comma 14 exists on this line. And oftentimes, we can convert back and forth between point slope and slope intercept really easily. And let's go ahead and look at an example of how to do that. So if we start with the equation y minus 5 is equal to 3 times x minus 2, and we want to convert it into the slope-intercept form. How would we do this? Well, first we're going to start by multiplying this 3 into this parenthesis here. So y minus 5 is equal to 3x minus 6. And then we're going to move over this 5 to the other side. And you see that we get y is equal to 3x minus 1, which is the same equation that we were just working with. And if we wanted to go backwards, we can just go ahead and use a point, any point that we know exists on this line, and plug it in. So we know that the equation for the point-intercept form is y minus y1 equals m times x minus x1. So if we know some point and the slope, here we know the slope is 3, and we just figured out that the point is 5, 14 from the previous problem we solved, then we can plug this in here to get y minus, sorry, this y kind of looks like a 4, y minus 14 is equal to 3 times x minus 5. And that's how we can convert. The standard form looks quite a bit different than the previous two we just looked at. And typically, you won't use it whenever you're trying to find a point on the line. Instead, you're probably going to use it whenever you're trying to set up a systems of equations or some constraint in more advanced math. So for example, instead of using this equation to find a point on the line, instead we're going to solve a systems of equations with this. A systems of equations is two different lines that might intersect each other at some point. And the entire reason why you would solve a systems of equations problem is to find what point they are intersecting each other. So for example, if we have these two equations here, we would go ahead and first try to isolate a variable. Here y is alone, so it's definitely going to be the easiest. We're going to move this 2x to the other side to get y is equal to 10 minus 2x. And then we're going to plug in this y value here for this y value over here to solve for that x value. So we get 3x minus 10 minus 2x is equal to 1. And then we just go ahead and solve. So 3x minus 10 plus 2x is equal to 1, or combining like terms and moving the negative 10 over, 5x is equal to 11. So x is equal to 11 over 5. Then we plug that back into either equation to figure out what y is. Since we already know y is equal to 10 minus 2x, we can just go ahead and plug in this x equals 11 over 5 directly here to solve for y. So y is equal to 10 minus 2 times 11 over 5, or 10 minus 22 over 5. And then we can go ahead, change this 10 into a 50 over 5, since that is equal to 10, and subtract 22 over 5, and we see y is equal to, and let's go ahead and move this slightly, and we'll get rid of this and this as well. We see here that y is equal to 28 over 5. So that's an example of how to use a systems of equations to find a specific point where two lines are intersecting each other. And that point for this problem would be 11 over 5 and 28 over 5. And really, the standard form and this process of solving systems of equations is foundational for fields like linear algebra, optimization, and even machine learning models. The point-slope form becomes a foundational form in calculus as well, where we see y minus f of a is equal to f prime of a times x minus a. And you don't really need to understand fully, just know that this is your point slope used in calculus to represent a tangent line. The slope-intercept form helps us visualize rates of change, especially like in linear approximations in calculus, and the standard form lays the foundation for solving equations, defining constraints in linear programming, setting up conic sections, and even looking at equations for circles. All three of these different forms have extreme applicability into different fields of math. You don't have to use them solely for looking at a line. So don't just memorize which form to use, understand what each one is saying about the line, because once you know how they fit together, you're not just solving a problem, you're learning how to think truly in terms of systems and perspectives. If you found this helpful, give it a thumbs up, subscribe, and check out the next video for more visual examples and deeper dives. Thank you so much for watching. See you in the next one.